Okay, this is 6.2 homework help. 8 questions, pretty simple. Don't forget, you have to go into Savvis to open this, not Canvas. To get it open in Savvis, you have to go to Canvas, click on any assignment in Canvas, then click on the Savvis button, then go to the assignment that says Lesson 6.2 HW. Okay, number 1 says multiply. What property are we going to use? Distributive. We're going to distribute the 2x to multiply by each of those terms. So 2x times x squared is what? You want to make it simpler by putting some clothes on these naked variables?
Ew.
I know, you guys don't like that, it's funny. This x has a naked exponent, so I'm going to put a 1 there. This also is a naked exponent, put a 1 there. There's a naked coefficient, so we'll put some clothes on it. Okay, that'll make it easier. 2x to the first times x squared would be what? Oh, this is also naked. Put some pants on that thing. There we go.
Could it be 2x to the third?
Yes, good. You guys get that? 2x to the third power. Why? Because 2 times 1 is 2, and x times x squared is x cubed. Same basis, add the exponents. 1 plus 2 is 3. Good, that one's done. Now we do 2x times negative 1x to the first power. 2 times negative 1 is negative 2, and x times x is, yep, x squared. And then our last term, 2x to the first times 5. So 2 times 5 is positive 10, and then x is x. That's it.
Wait, what would mine be?
Well,
It's 6 for the 5.
so everything's the same except there's a 6?
Where your 5 is, mine's 6.
So everything's the same except you have a plus 6 instead of a plus 5? And you aren't able to do that on your own?
No, I'm like, do I multiply them or?
Well, how did I get my 10x? Okay, so if I multiply, you multiply.
Oh. Take that down.
Okay, ready to move on?
Yeah, I think that's it.
That's it. You can check to see if there are any like terms. There are not. It's also in standard form already, so we can move on. Same. We're going to distribute. We're going to do 4x times 3x squared. Multiply your coefficients. 4 times 3 is? 4 times 3 is 12. X, whoop, naked. X times x squared is?
12. X squared.
X to the first times x squared is x to the third power, or x cubed. That one's done. Now we have to multiply 4x times negative 3x. So we have 4 times negative 3 is? 4 times negative 3 is negative 12. X times x is? Yeah, x squared. Now that's done. And lastly, we have 4x times 5. So 4 times 5 is? 20. And x is x. That's it.
With 5 times negative be -10.
Mhm. Another one, this one is like actually spelling some words here. 8ab, and it's got za and ya. No? I guess that wasn't funny at all. But it kind of looks like it's trying to spell something. It's trying to play Scrabble up in here. So we have to distribute again. Multiply. 8ab times xa cubed. That is a lot of weird stuff. First, let's slap some clothes on, put a shirt on these guys. All of the exponents that don't have, all of the variables that don't have exponents, I'm going to go ahead and put some exponents there. And all of the variables, the terms that don't have coefficients, I'll put some coefficients there. So I have everything filled in and I'm ready to multiply. Multiply your coefficients first. Coefficients are the numbers. 8 times 1 is 8. A times a cubed is I'm going to write this down here so we can zoom in on it, okay? 8ab times 1xa cubed.
Well, how are the parentheses?
What?
Well, how are the parentheses?
What do you mean, what happened to them?
They're-
The parentheses is indicating multiplication. And since I'm in charge of how I write multiplication, I chose to write it like that because I can do whatever I want, and so can you. You can write multiplication like that if you want to. I could also choose to write it with an X, but that would be really stupid, right? Because that would be so confusing with that. Why are you not okay with me writing it with the...
No, I just thought, like, I thought you were rewriting the whole thing. And then
I'm not rewriting the whole thing. I'm just pulling this part out because I can see that you guys are already confused. And if I take this and zoom in, it might look easier. In fact, since these are being multiplied together, but also the 8 is being multiplied times the A and the B, right? Do you agree that 8AB is the same thing as 8 times A times B? Do you agree with that?
Mhm.
Do you agree that 1xa cubed is the same as 1 times x times a cubed? Do you have to do this every time you solve one of these problems? No, but I'm doing this to show you what's happening. So I'm going to go ahead and rewrite it again. I'm going to write 8 times a times b times 1 times x times a cubed. Do you agree that all of these are being multiplied together so we can multiply them together? Let's do our coefficients first. That's our steps, right? We wrote that in class. You all right?
Yeah.
8 times 1 is 8. And if you want, just cross it out after you're done multiplying them. Now let's go in alphabetical order. A to the first power times A to the third power, same bases. What do we do with our exponents? What?
I'm gonna add.
Add your exponents. So what would that be, Abs? a to the 4th. Very good. I'm going to cross these out. Emily, are you following along? Continuing in alphabetical order, because that is always how we order our variables, although they did not do a very good job here. We're going to fix that. B is next, and B is just B. Done. All that's left is X, and X is X. So our very first term, after multiplying the 8ab times the xa cubed, is going to be 8a to the 4th bx. We didn't do anything different. We just applied all of our rules for exponents and multiplying. And that's only the first term. We still have to distribute the rest. Emily, what's wrong?
Nothing. Oh, sorry. I thought you were talking to me.
I just don't understand what you're trying to do. Because then I thought you were rewriting the whole thing, and then you didn't put the parentheses, and that confused me. And then like with all the other like.
I know, but I clarified that, right? So is that still confusing you, or?
No, except then wait. There's so many letters, I can't figure out what.
I know. There are so many letters. That's why I decided that you have to remember that you're in control of how you solve the problem. You don't have to solve it in your head. You don't have to go, well, how do I multiply those together in my head? Eventually, you probably will be able to. I would hope that eventually, when you practice this a lot, like I can do it in my head because I've been doing this for years now. But when I started, I would have to pull these out and say, if I'm multiplying them together, let me just write a multiplication problem with this term times this term. So I wrote that multiplication problem because you can be in charge of how you solve it, as long as you're following the rules. If these are being multiplied, show that they're being multiplied. Then you can also be in charge of, hey, if this term is technically all multiplication, then I can rewrite this term to be 8 times a times b. The reason I wrote it all out like that, even though it's this is the exact same thing as this times this. I separated everything. You're zoning out again. I separated everything because it helps me organize the information. I'm not trying to make it easier or harder. I'm just trying to keep it organized so I don't like get confused as to how to like move everything together. So when I multiply, do you have different numbers? Do you want to work with your numbers? Okay, let's finish this one first, and I don't want you to even look at your numbers right now. We're going to finish this, and then we'll work with your numbers. I'm going to erase this so I have room to be in charge of the way we do the next one. I think you guys also get frustrated because you really want to be able to answer your question quickly after I answer mine, but think about how long I spend answering my question. It's okay if it takes you that long too, I can wait. Okay, so that's my first term. I'm going to cross it out because I'm done. Now I have to distribute my 8ab to my 1ya cubed. I'm going to draw an arrow. And because I'm in charge of how I solve this, I'm going to take my 8ab and show that I am multiplying it, because that's what distributing is, right? Multiplying it times this term. 1ya cubed. Didn't do anything, just wrote it down here instead of trying to keep it in my head. Does that make sense? Okay. From here, because I've been doing this for a while, I could just go 8 times 1 is a times a cubed is a to the 4th, b is b, and y is y. I could, but I'm not doing that right now because I want to show you guys that you are allowed to show it as just all multiplication, because that's what this is. This literally says 8 times A times B times 1 times Y times A cubed. It's just all multiplication. That's the only operation that's here, except for this, technically this has an exponent, but that can't be simplified at all. So I'm going to rewrite it. 8 times A times B times 1 times Y times A cubed. I still haven't simplified anything yet. I'm just organizing it the way that I can see it better. Now I'm going to look at my parts here. First step, multiply the coefficients. Again, that's a fancy word for the numbers. 8 times 1 is 8. Then we'll go in alphabetical order because that's the way we write things in standard form. They didn't, that's wrong. We'll do my A's next. A to the first power times A cubed is?
A to the fourth power.
A to the fourth power. Done. B is B. Done. And Y is Y. Done. Does it seem like it's getting easier now? No? Did you see how I got this? Okay. It does feel like a lot of steps because there are so many variables here, but just go slow and then you won't miss anything. So I have a positive, I'm just going to write this as my second term, positive 8A to the fourth B, Y. Almost the exact same thing as this, but this has an X and this has a Y. So they're really close to being like terms, but they are not. So we're not going to combine them, we're just going to leave them as is. In order to be like terms, the variables and exponents of the term have to be exactly the same. Okay, we're done with that. My last is 8AB times -5. Now, could you do this one in your head? Absolutely. 8 times -5 is what? -40. And AB is AB. So I didn't go to all the trouble of writing that one out since there weren't any variables here. It was super simple to just multiply my coefficients and then write the variables that are in that term. That's the final answer for this.
Mine is just AB for the first number.
Okay. Okay, does everybody understand what I did? And do you want to practice with yours now? Okay. All right, go ahead and give me yours.
7AB parentheses XA plus YA to the third power plus 5.
Plus 5? Okay. Okay, what are we multiplying first?
So 7AB and the X.
Okay, so I'm going to write it like this. 7AB times XA. Would you like to just multiply it, or do you want to write it out with all multiplication? That's your choice. I'm okay with you just multiplying it. Do you want to just multiply it? Okay, you tell me what, hold on one second. You tell me, like, multiply your coefficients first. If you want to stick a 1 in front of those variables, that's 7, okay.
At this time, anyone taking the CLT test, please report to the podium with your lunch and backpack. Thank you.
Okay, so we have 7. What do we multiply next? Well, we have to do our variables separately. Yeah, A times A is A squared. We also know that A to the first times a to the first would be a to the 1 plus 1, which is 2. So any way you think about it is correct. What do we multiply next? B. Can that be multiplied by anything? No, it's just B. Done. What about x? Just x. Done. That's your first term. So you have 7a squared b x. That's your first term in your solution, okay? I'm going to go ahead and cross this out because I want to feel accomplished, like I'm checking something off my to-do list, okay? So now I have 7ab times ya cubed. If you want to, we don't have to write it out here. Do you want to just multiply like this? Okay. 7, positive 7, so we put plus 7. Yep. B. Y. Very good. I'm going to cross it out, so we're done with it. Lastly, yep, I'm going to write it here because I ran out of room. Plus 35. AB. You did it. I didn't do any of that. You did it all. You got it all right.
It's like, can you do my numbers? Because I'm like confused again.
Okay. Were you totally following along with those two examples?
Yes.
Oh, okay.
Just kept dropping stuff. Yeah,
Okay, Emily, go ahead. What are your numbers?
Negative 6ab.
Oh, you got a negative. That's mean. Okay.
Parentheses. XA cubed
Okay.
plus YA cubed minus 6.
6. Okay. So one thing that we can do, if you want to, I think it's good to give every variable an exponent. So a to the first, b to the first, x to the first, a is already cubed, y to the first, a is already cubed, and that's it. Another thing you can do is put some clothes on those coefficients. That coefficient is naked, give it a 1. Coefficient is naked, give it a 1. That's all we have to do. Is that just weird? Good, it's weird and you're paying attention. Good. So, we're going to distribute to this guy first. We could pull them out and write them so we can see them a little bit more clearly. Or you can just go ahead and multiply, starting with your coefficients, and then continuing in alphabetical order. Do you want to rewrite it, or do you want to just try to do it like this?
I wanna do the negative 6 times a times b.
Oh, you want to write it all out? Okay. So I'm going to first write out my term here. Negative 6a to the first, b to the first. I'm going to write times this term. 1x to the first, a cubed. Then I'm going to write it again, and I'm going to show that everything is being multiplied together. So I'll write negative 6 times a to the first times b to the first times 1 times x to the first times a cubed. Nothing wrong with doing it that way. Seeing it nice and clearly. We start with our coefficients. So what do we get?
Negative 6
Yep.
times 1 is negative 6.
Good. Oh, you said negative 6, so I thought you were giving me the answer. You were just reading it. But that's good. So we got negative 6. Then what do I multiply?
A squared
Cubed.
cubed.
Okay.
And then that's going to be a to the fourth power.
Good.
And then b's just going to stay there, so it's going to be
B. Okay.
b. And then you have to, and then it's just going to be x.
Yep. That's your first term. And your final answer. And then you're just gonna do the same thing to the next term. Done with that, we're going to go over here. So we have -6 times a to the first times b to the first times 1 times y to the first times a cubed. So for our second term, what do we get?
Sorry.
It's okay.
-6.
Okay.
And then a to the fourth power.
Yep.
B.
B. Okay.
Y.
And y. And I probably should have crossed these out as I went along. A's are done, B's are done, and now y is done. Got everything? That's my second term.
So it's going to be -6a.
And then the last one is super simple because this doesn't have any variables. So you just multiply your coefficients and then slap on the AB. So what would that be?
It's positive 36.
Positive 36, AB.
Okay.
We good?
Excuse me. Yeah.
Do you get it? Simplify the product using the distributive property. And we're going to do this in class today, but I'll give you a little preview. Now, a minus 5 times a minus 3. We did yesterday in our lesson, we would set up a table to multiply, which is, I think, just as good a method as the distributive property. So in the end, if you like the table method more, you can do it. But this one is specifically asking for the distributive property, so let's just follow the directions. Now, it's gonna look really confusing when I draw my arrows. So I'm going to draw the arrows first, and then I'm gonna write it out, what I'm doing. The first thing is, I have my A, and that needs to be multiplied times A, and times -3. So this is going to get distributed to the A and to the -3. My -5 is also being multiplied by this expression, so my -5 is going to be multiplied times A and times -3. That's a lot of arrows.
Yeah.
So we can rewrite this expression by showing that A is going to be multiplied times A and -3. So we're just taking our first term of the binomial and multiplying it times this binomial. And then we also have a -5, so a -5, which is also being multiplied times this binomial, A minus 3. When you rewrite these factors like this, you're basically taking your A and your -5 and you're breaking them up so that they can each be multiplied times the A minus 3, times the second binomial. Now our arrows won't be so clogged up, and we'll be able to distribute here, and then distribute here and here. Totally same thing as the arrows above, but kind of making it one thing at a time from left to right.
What did you do?
Guys, be totally honest with me, and I'm not mad at all, but just be totally honest with me. Do you kind of zone out here and there when I'm doing the explanation?
Yes.
Yeah, I think that's what's happening, and I'm not mad about it because it is a lot of information, but I honestly think you guys, your brains are like flickering. You know, like a light bulb flickering? It's like on and off, on and off, on and off. Like the switch is on, but it's like flickering. I think that's what's happening. So,
I'm just like really tired.
Yeah.
Just don't feel good.
okay. I'll explain the whole thing again, but try not to flicker, okay? I need you guys to just be on with no flickering. You know the kind of like the lamp, it's flickering, and then when you go to fix the light bulb, you realize that the light bulb was a little loose.
When you say flickering, I don't know why, but the first thing that comes to mind is that one Freddy's game. I don't know why.
What game?
The Freddy's game. Not
That-
gonna make me mad. Yes.
That's creepy.
I know. And then like the dude just comes out of nowhere.
Okay, all I'm doing here is rewriting the binomial. The binomials. I'm rewriting the multiplication of the binomials. Do you see that I haven't done anything except copy
Yes.
this to here? Is everybody's on, right? No flickers?
Yeah.
Good. Now, do you agree that if this whole expression is being multiplied by this whole expression, that means each individual term is being, don't flicker, each individual term is being multiplied by all of the other individual terms. And I can prove that with the table method. I'll draw my little tic-tac-toe board, my table, and I can show a minus 5, so a minus 5, and then a minus 3. A minus 3. Do you agree that I have to multiply each term together?
Yeah.
So I'm really doing 4 separate multiplication problems.
Wait, hold on, don't go on.
Okay. This is the table method, and if you like that better, you can stick with that. Then you would just combine those terms and write in standard form.
Okay.
The distributive property is doing the exact same thing. It's multiplying the a's together to get a squared. Then it's going to multiply the a, this a times the negative 3. What it's doing is taking this a and multiplying it times this a, and then multiplying it times negative 3. So it's taking the a in the first binomial, the a minus 5, and it's multiplying it by a and by negative 3. We're just showing it with arrows instead of a table. Okay? So this a has to be multiplied times a and negative 3. That's what those arrows are showing. And then since there's also a negative 5 here, as we see in the table, the negative 5 also has to be multiplied times a and times negative 3. So the negative 5 also is being multiplied times a and negative 3. So this, the first a is being multiplied times a and negative 3, and negative 5 is being multiplied times a and negative 3. That's exactly what's happening in the table. Here we're just writing it horizontally with distributive arrows. Then we just multiply from left to right. We distribute. A times a is a squared. A times negative 3 is negative 3a. Done.
Blessing.
Negative 5 times a is negative 5a. Negative 5 times negative 3 is positive 15. 4 answers here, 4 answers here. Circle your like terms and write in standard form. A squared minus 8a, because of the negative 3 and the negative 5, plus 15. And that's how we do it. But if you like the table better, do the table.
Wait, Miss, I don't go on it because it's
Okay.
Enthusiast.
I want to, you guys can keep working. I do want to skip to harder problem, just so I can get it on video. Okay, the next question is exactly the same, so it's just more practice. For number 6, just take a quick look at this. If you haven't had my class yet, don't worry. We're gonna do this in class today, and it's no different from that table. You just have 3 numbers at the top instead of 2.
This question is
That was question 6. So I'm gonna skip this one because we're gonna do that in class today. We're gonna do one just like that in class. Same thing there. And then I think the last one is the, yes. This is the one that I wanna go over on video, so everybody has a video of this, okay? Find the polynomial in descending powers of x, that just means write it in standard form, representing the area of the shaded region. The area of the shaded region. So we have a big square, and the big square has an area, and that's the whole area of the square. We also have a little square inside, and that has an area. But it just wants the area of this shaded region. How do we end up with just that area? Don't worry about the x's and the stupid numbers. Yeah. No, don't tell me how to find areas. How do I end up with just the area of this? If I have the whole area, but I don't want this area, what do you do when you don't want something in math? Yeah, you minus it. That's exactly what you do. If I have 20 monkeys and I don't want 10 of them, I subtract them.
You don't want the bed.
I throw my hands and say, here, get the banana, right up. So weird, I don't know why.
You donate them to Mario.
Donate them to Mario Kart, okay? You subtract. So I'm gonna take the total area and I'm gonna subtract the inner square, okay? So I'm gonna take the area of the large square and then subtract the area of the small square to get the area of the shaded region. And that requires me to get the area of the large square, which would be x plus 4 times x plus 4. Because we have to do the side times the side, or the side times itself. Then the area of the small is simply x times x, which we could rewrite as x squared. Then, once you multiply these and get your polynomial, you'll just subtract this area, which is x squared, and you'll get the area of the shaded region. Oh, we have time. We have 2 minutes. So I'm going to go ahead and multiply these, okay? Let's go ahead and do the table method. It's nice and easy. I'll do my tic-tac-toe board over here, and I have x and a positive 4 and x and a positive 4. X times x is x squared. X times 4 is 4x. Don't flicker. 4 times x is 4x, and 4 times 4 is 16. Like terms get combined when we write it in our final standard form. X squared is our beginner. 4x plus 4x is positive 8x, and then we have positive 16. That's the area of the larger square. What do I have to subtract? Yes, which is x squared. You can go, Zach. X squared.
I don't want to go, just upstairs out there.
Oh, okay.
Upstairs.
So I'm going to subtract the x squared, and that cancels out. So what am I left with? This. That's the area of the shaded area.
Area of the shaded area.
That's the area of the shaded area. I just wanted to get that on film, and that should be good for today. Great job, guys. No more flickering.